All right, welcome back to a new term. This is trigonometry that we're going to kick the term off with. Now, we should be familiar with three of the ratios. Remember, these are ratios of side lengths in right-angled triangles. We know that for certain angles, the ratio of sides will always be the same. So let's have a look at the ratios that you should be familiar with. First of all, we have the sine ratio. So the sine of theta is equal to the opposite side divided by the hypotenuse. That's the ratio for the sine of an angle. The cosine of an angle, in a right-angled triangle, the cosine is found by finding the adjacent side divided by the hypotenuse. And the tangent ratio, the tan of theta, this is the one you've probably used the most, will be the opposite side divided by the adjacent. How do we go about remembering those? Well, you probably recall SOHCAHTOA is the mnemonic that we use to help remind us. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent ratio is opposite over adjacent. Pretty straightforward. What I'm going to do today, just as a little bonus, I'm going to introduce you to a couple of ratios that, although we won't be using them specifically this term, we will be using them as you progress into senior mathematics. So I want you to just have a look at them now and realize that they're not the only relationships I could find for that angle. I could find the reciprocal of each of those, and that would also be another ratio that I could use for the triangle. So together with sine and cosine, they both have there are a couple of reciprocal relationships. So the reciprocal of sine is called the cosecant, or cosec is the way we usually abbreviate that. And that's simply, as I said, the reciprocal. So that's the hypotenuse divided by the opposite. The secant ratio, usually just abbreviated to sec theta, is the hypotenuse divided by the adjacent. And finally, the reciprocal of the tangent ratio is the cotangent ratio. We'll usually just write that as cot theta, and that is adjacent divided by opposite. Now these will come up when we get to calculus of trigonometric functions and a few other areas. We will come across those, so it's good for you to just be familiar with them now, know they exist, and in terms of finding those ratios, it's just as easy as finding a sine, cosine or tangent ratio. There's really no difference. Let's go down and have a look at just the basic sort of questions that we're going to be dealing with in the first couple of lessons. So here we are. William's on a famous television show and he's asked to label a right-angled triangle. Help William label the sides with opposite, adjacent and hypotenuse. Pretty straightforward. We're all familiar with this now. Remember, the hypotenuse is the longer side. It's always opposite the right angle. So across from the right angle, you'd be putting an H for hypotenuse there. The opposite side, I still draw the arrow in. It just makes it easier for me depending on the orientation of the triangle. It's very hard to mess it up. Then the opposite side, the side that's not forming part of the angle given, so that's the opposite side. And adjacent means next to. Make sure you label the hypotenuse first, so then the adjacent must be the other one that's next to it. You're all going to be all over that. That won't take you very long to get through that. Let's have a look at another one here. Cyrus and Sarah are testing each other on trigonometric ratios, good students that they are. And Cyrus asks Sarah the following question: which of the following is true for the triangle above? Well, to answer these questions, simply go ahead and label the triangle. So we've got the hypotenuse there. Across from the angle given is the opposite. There's the adjacent. So which rule is it that's going to involve the opposite side and the adjacent side? Because they're the two angles that I was given, the two side lengths, sorry, that I was given, the x and y. So which rule is it that relates those two sides? Well, it's going to be the tan rule. And remember from SOHCAHTOA, make sure you get it in the right order. Tan is opposite over adjacent, which in this case, I should have the tan of A being the opposite side length is x and the adjacent side length is y. There we have it right there. The tan of A is x over y. Again, nothing too difficult there. As you move on, we'll actually go ahead and start calculating some values. We might save that for another time. I'm sure you already remember how to do it, but I don't want the videos to go too long. Get stuck into those introductory questions, and then we'll come back and see you in the next video with a couple of examples. Cheers.